Can you solve this geometry challenge? Here's the question. Given this triangle having a base equal to 5 units, from this point, let's draw a segment, and that is perpendicular to the base, which measures 5 units also. And from this vertex, let's create a segment that is connected to this segment 5 square units, and also perpendicular to this side, having a measurement of 1 unit. Now the question, what is the area of this blue triangle? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solutions in 3, 2, 1. Alright, the answer to this question is 14 square units. So the area of this blue triangle is 14 square units. And of course, the question is, how do we get 14 square units? In this video, I will show you 3 different methods to answer or to arrive at the correct answer, 14 square units. So the first method is using Ptolemy's theorem, because this opposite angle equals to 180. In short, this quadrilateral can be inscribed in a circle. The next solution is from our friend. So we have to represent the area of this whole quadrilateral in 2 different ways. And that is from Sir Murat Agsu. So thank you, sir, for sharing your solution. And the third one is my favorite, rotating figures. So we can solve this question mentally if we know how to rotate some figures. Alright, so let's start with the first method, the Ptolemy's theorem. Now, to answer this question using Ptolemy's theorem, what we're going to do is to connect this point to this point, or the diagonal of this figure. Because what we're going to do is to focus on this right triangle, isosceles right triangle, because these 2 sides are equal. And let's get its hypotenuse. So we have 5, 5. And if we get the hypotenuse, this is the square root of 5 squared plus 5 squared using Pythagorean theorem. This will give us 25. Square root of 25 plus 25, or simply square root of 50. And simplify square root of 50, this will give us 5 times square root of 2. So meaning this red segment simply equal to 5 times square root of 2. Alright, now let's focus to this right triangle. And again, using Pythagorean theorem, we can get the other side of this triangle. So this is just square root of the hypotenuse squared, 5 times square root of 2 squared, minus this leg 1 squared. So this is 50, and square root of 50 raised to the power of 2, this is 50. So 50 minus 1 squared, this will give us 49. And square root of 49, this is just 7. So the measure of this side is simply equal to 7 units. Now, what we're going to do is to focus on this figure, because we want this figure. And also, since the opposite angles adds up to 180 degrees, in short, this is a cyclic quadrilateral. So we can put this quadrilateral inside our circle. And now, let's call this segment, this chord, as X. And there you have it. Let's use the Ptolemy's theorem. So using this figure, we can say that, applying Ptolemy's theorem, we can say that segment AD times BC plus CD times AB equals to the diagonal BD times AC. Now, using this Ptolemy's theorem to our figure, we can say that 5 times 7 plus 5 times 1 equals to X times 5 times square root of 2. Using this, we can solve for the value of X. So now, let's simplify this. We have 35 plus 5 equals 5X times square root of 2. Now, 35 plus 5 is 40. And divide all of this by 5 times square root of 2. This will give us X as 4 times square root of 2. So we get that the length of this X is 4 times square root of 2 using Ptolemy's theorem. And now, the side of this triangle are now complete. So we can use what we call the generalized theorem's formula. So we have a video of this, of the proof of this generalized theorem's formula. So now let's use this. So the area of this triangle is equal to 1/4 times the square root of 4 times a squared b squared minus the quantity a squared plus b squared minus c squared raised to the power of 2. Now, let a be equal to 5, b equal to 7, and c equal to 4 times square root of 2. Either way, if you want a as 4 times square root of 2, that's okay. Alright? Now, we want a squared, b squared, and c squared. So, if a equals to 5, a squared is 25. If b equals 7, b squared is 49. And if c is 4 times square root of 2, c squared equals 32. Now, substitute all those given values to our formula to find the area of this triangle. So, we have 1/4 multiplied by the square root of 4 times 25 times 49 minus 25 plus 49 minus 32 raised to the power of 2. And what we're going to do is to just simplify this. Simplify the number inside the radical sign. This will give us 1/4 times 56. And 1/4 of 56, this will give us 14 square units. And that is the area of this blue triangle. And there you have it. So this is our first solution. Now, how about the solution of Sir Murat Agsu? So let's begin his solution. So using this information, we know this side length is 7 units. And what we're going to do is to divide this quadrilateral again. And now, let's focus on these two right triangles. So the area of this quadrilateral, the whole quadrilateral, is the area of this small right triangle plus the area of this isosceles right triangle. So using the formula, base times height over 2. In short, the whole area of this quadrilateral can be written as 7 times 1 over 2 plus 5 times 5 over 2. Or simply 7 over 2 plus 25 over 2. Or 7 plus 25 is 32 over 2. Or simply equal to 16 square units. So that is the area of this entire quadrilateral. Now, how about if we use these two triangles? So how do we get their areas? So let's call this angle be equal to alpha. And this angle right over here simply equal to 180 degrees minus theta. And now take note that this quadrilateral is a cyclic quadrilateral from our first solution. So, to find the area of this triangle given its included angle, we will use this formula, 1/2 times AB times sine theta. So, adding the area of these two triangles, this will give us the area of the entire quadrilateral as 1/2 times 1 times 5 times sine theta plus 1/2 times 5 times 7 times sine of 180 degrees minus theta. Now, simplify. This is just 5 over 2 times sine theta plus 35 over 2 times sine of 180 degrees minus theta. But take note, this identity shows that sine of 180 degrees minus theta is the same thing as sine of theta. This is the identity that we'll learn in our trigonometry class. In short, we can replace this as sine theta. Now, simplify this. 5 plus 35 is 40 divided by 2. This will give us 20 times sine theta. And this is also the area of this entire quadrilateral. Now, we can write the area of the entire quadrilateral in two different ways. The first one is 16 and the other one is 20 times sine theta. So why not? Let's equate these two expressions. And let's solve for the value of sine theta. So divide both sides by 20 and simplify. This is 16 over 20 or 4 over 5. Now using this, we can now solve for the area of this blue triangle. Now also take note that sine theta is the same thing as sine of 180 degrees minus theta. Now what is the area of this blue triangle? This is just 1/2 times 5 times 7 times sine of 180 degrees minus theta. And we know this is just sine of theta. And sine of theta is 4 over 5. Now, multiply 1 over 2 times 5 times 7 times 4 over 5. 5 cancel out. 4 and 2 cancel out. So this is just 7 times 2 or simply equal to 14. And again, we get that the area of this blue triangle simply equal to 14 square units. And there you have it. That's our second solution. So thanks to Sir Murat Aksu for sharing your wonderful solution to us. Now, let's have my third solution. This is my favorite, rotating figures. So let's begin. Now, one thing is for sure. If we call this theta, this angle must be 180 degrees minus theta. Now, at this point, the key in this solution is this triangle. So now, let's focus on this figure. And let's focus on this triangle. Now, take note, this side is 5 units, and this is also 5 units. And theta plus 180 minus theta, this is just 180 degrees. In short, if we rotate this figure like this is just a straight line because 180 degrees minus theta plus theta, this is exactly 180 degrees. And this is the same thing as 5 units. In short, also, this is a right angle, and if we rotate this figure, this is also a right triangle. So we created an isosceles right triangle having an hypotenuse as 8 units. Now, we know for sure this is an isosceles right triangle. In short, this is 45 degrees, is 45 degrees. Now, if we want to get the height of this triangle from its vertex, let's draw a height. This is just half of this hypotenuse because, again, we can fit this isosceles right triangle inside a circle. In short, this is a radius, and this is 4 units. Therefore, if we draw the height of this blue triangle in this position, this height simply equal to 4 units. And there you have it. We can now find the area of this blue triangle using the formula 1/2 times base times height. The base is 7, the height is 4, and 4 times 7 divided by 2, this is 28 divided by 2, and also this will give us 14 square units. And therefore, given these 3 solutions, we get the same answer as 14 square units. And as always, we are done.